Okay, now members, let us see the examples. Now here under frictional force, we are going to start with the horizontal plane. But now, specifically on the horizontal plane, when the force is applied on the body horizontally, then we shall swing is applied at an angle, then we shall move to inclined plane. So let us start with this one. Calculate the maximum frictional force which can act when a block of mass 8 kilograms rests on a rough surface and the coefficient of friction between the surfaces is 0.2. So there you just draw a simple sketch. So here we have a body. Whenever we have a body, we expect a reaction, which is R, and then we expect a weight. This way we get the mass times gravity, which will be 8 now times D. Now they're asking for the maximum friction. So our maximum friction which can act is Fr at maximum friction is going to be this. It's not clear, this one is the coefficient of friction and this one is the resultant. So from here we can start our R is going to be 8D because here the body is not moving upwards. So the equilibrium. So meaning my R will be, when you put there, now we have, the question is also giving us our mu as 0.2. From here, the coefficient of friction is always mu. So now our result, our frictional force F is going to be 0.2, then times 8D. So our F will be now 0.2 times 8 times 9.8, and the maximum frictional force. At maximum, always the frictional force is going to be mu times R. That was one point there. So here I'm getting 15.668 newtons. This is the maximum frictional force that can occur on that body. A block of mass 10 kilograms rests on a rough horizontal surface and the coefficient of friction between the body and the plane is 0.8. So you summarize the question. So they are giving mu. So our mu is 0.8. Okay. If the body is in limiting equilibrium, always our frictional force, our F will be going to mu R, because we are in limiting equilibrium. So whenever we are in limiting equilibrium, friction has reached its maximum, and its maximum is this, but the body is about to move. So that's the case there. If the body is limiting equilibrium, that's the case, calculate the horizontal force P applied on the body. So we draw our sketch. I have a body here. Of course, it's going to be having a resultant, R. The plane is horizontal because we're horizontal planes. Okay, of mass 10 kilograms. If now they are giving us mass, we get, this one is going to be having a weight, which we get 10 kilograms. So we get 10 times the gravity. Then there is a force which is acting on this. This force is called P. Now, if there is a force, remember, if P is going in this direction, then the friction will be opposing. So we are going to be having our friction force in this direction here, because it's always opposing. So remember, when you put something like this, it will come. So meaning this will oppose its motion. So if you go in that direction, and this will oppose the direction like that. That is the horizontal force P that applies on the body, because it's limiting equilibrium, that is the case. So are they giving us anything? Yeah, they are giving us this and this. Now, so from here, our R is going to be 10 G, which will be 10 into 9.8. So our R is going to be 98 newtons. If we have R, know that this force is going to be equal to this, because in equilibrium we don't have an acceleration. So acceleration is 0. The idea of all that is from the force should be equal to the mass times acceleration, but acceleration is 0 because we're in equilibrium. So the body is at rest. So here the body at rest. So it's that our acceleration is going to be 0. So that's the basic of that. In simple terms, we are getting this friction minus this equal to the mass times acceleration, which is 0. That's why they are just equating them. So our F, from there our F is going to be equal to our P. And what is our F? Our F is mu R equal to P. So we have our mu as 0.8, then our R as times 98 will be equal to P. So P is there for B. So it would be 78.4 newtons, and you have it there. So that's why we have this, because at the limiting equilibrium, when they take the same limiting equilibrium, frictional force is this. When they say maximum friction, it's equal to this. So when you know those terms, the rest are going to be very easy. Very easy for you. When a horizontal force of this, they are giving us now a force, okay, applied on the body of weight. Now they are giving us weight. Resting on a rough horizontal plane, the body is found to be in the limiting equilibrium. Find the coefficient of friction between the body and the plane. So we draw our simple sketch. So we have our body. This body is having now a weight. There's a difference between weight and mass. Now they are giving us a weight. So the weight of this body, they are telling us is 29.4 newtons. Now here they have been giving us mass. That's why we are multiplying by gravity. But here they are giving us weight. I think you know the difference. When they give you weight, it's what you put there. Then this one will be having a reaction force. Then we have a force being applied to this as 14.7 newtons. If you have a force and the plane is rough, we are going to have, of course, a frictional force opposing that motion. I think now that's all. Then they want us to get the coefficient of friction. So now from there I see that our R is going to be 29.4 newtons because we're in equilibrium. After getting that, you know that now our F, so our F is equal to 14.7 newtons, but our F is mu R equal to 14.7. We have our R, so we have mu into our R, 29.4 equal to 14.7. Then from there, such our mu will be 14, 29.4, and our mu is going to be 0.5. Mu is a ratio, so you don't expect anything like units. So that's how, now these are the basics you have to know. I was giving the basic examples. Now we are going to, as we move, we are going to tighten a little bit so that we can leave these ones and we revisit the area basic example. So that's it, members. Don't forget to subscribe the channel. Visit the playlists. That's where you are going to find all the topics you would like to look at. See you in the next lesson.